Hi everyone. My name is Berhanu Wondimu. I'm a thermal mechanical engineer from Intel. I'll be talking about some of the server level leak detection works we did. So transitioning from air to liquid, when I say liquid, I'll be talking about cold plate-based liquid cooling option. As immersion, we all know, if anyone talking about leak here, it's going to be what leak, right? Probably that might be one of the value propositions with the immersion side, not to worry about a leak. But on the cold plate side, the main concerns on the implementation side is the TCO and safety and reliability with a leak. So the TCO with the facility side of the infrastructure to get rid of the heat, depending on where this liquid cooling solution is implemented on the geo and location. So that's major concern. And also the from safety and reliability side, bringing water into the IT equipment, that's one of the concerns. So that's the area I'm going to be focusing on and some of the work we did. The scope of the work is getting off-the-shelf leak detection, leak sensors, and implementing into the server systems like the one shown here, and then integrate it and take the right course of action to mitigate the leak and prevent damage. So I'll have some quick demo to share as well. So again, we're not, so like I mentioned, the scope is if any of the integrators or customers would like to implement leak detection into their system, what kind of sensors are available out there in the market and how they can integrate it, and that's the kind of scope we put. We're not, we didn't consider any kind of customized solution because there are so many sensors out there, depending on what kind of communication protocol we can use and integrate into the system and program the BMC. We took 3 sensors we got on the market, and we implemented into, as you can see, it's the specifications. One has, from one of the vendors, is a 3-pin connector. The other one is 2-pin connector, and the other one is 4-pin connector. What we're trying to show here is if we have a sensor out there with different specifications, how can we implement in a system? Is it what kind of changes we can make to make it work? So that's what we're trying to show here. And a couple of those sensors have voltage outputs, and then one of those, the one we tried has frequency output. We'll be able to integrate all those 3 sensors into the system and make it work. And the other thing, normally, probably might have seen some of these rope-based leak sensors implementation on any pipeline applications. Normally, they put at the lowest point in the system. Maybe if they put it under a rack or any kind of a spill containment, they put those ropes. And if there is a leak, it's going to either signal alarm or trigger or take some action to as a mitigation point. So this primarily based on gravity, right? So what we try to do here is to optimize and make these leak sensors to be more of like active type of detection rather than the passive. Routing the sensors from inlet side of the QD all the way to the outlet side of the QD, following the flow paths, and also the weakest link on this setup are the connectors. Normally, unless the tube is punctured, you're not going to get a leak from the tube. The weakest links are where those tubes are connected, whether it's on the cold plate or manifold or on the QDs. So at those locations, you use these absorbent tapes to wrap around, and if the sooner we see a leak coming out, the sensors immediately will detect it. This would be more efficient way of detecting a leak, as compared to laying down the sensor inside the chassis or somewhere. So on the wiring side, again, to stick with the scope, we try to integrate on the system. The easiest point would be there are multiple fan header connectors on most boards. We'll be able to do the integration using those 4-pin connectors. So the 3 sensors with different specifications, but with different functionalities, we integrate it and be able to make it communicate with the BMC and system. For the BMC configuration, this is some of the testing we did. As you can see, these sensors, the signal is kind of discrete signal. For leak condition, it shows straight line, and then the same for no leak condition. And when immediately leak is detected, the state changes. So this is kind of straightforward for the BMC folks to do the integration. All they have to do is to map each of those pins to the right wiring, and then program it based on the appropriate threshold setting. And you need to do the threshold setting, that way any kind of false alarm from the sensor, that way we can prevent it. On the mitigation side, again, like the detection mechanism is different from sensor to sensor. Again, on the mitigation side, depending on application and the end user, there are multiple options. So because I'm focusing only on the server level, what we did is just these 3 actions as a mitigation plan. One would be when leak is detected, trigger alarm, and send notification to the data center operators, and safely shut down the system. And maybe some applications, they might put a little timer to just, instead of immediately shutting it down, put a timer. That way give time to the data center engineer, maybe to troubleshoot without stopping whatever workload is running. But that's left to the discretion of the customer. And then, of course, you have the event log to go back, and you can use that as for troubleshooting. So the mitigation plan, again, this is just example. Again, the end user can have a very complicated way of setup depending on how they want it or how they want to respond to any leak condition. So how it's laid out is when a leak is detected, it will signal alarm. That alarm notification could be maybe blinking LED shown somewhere, or maybe a buzzer. Again, it would vary from user to user. And then if you want to put a timer, if you don't want to put a timer, you can just straight go to soft shutdown. But if you want to put a timer, wait time, and then you power down the system for safety. Right. And then this is an example of what the event log looks like if you want to go back and troubleshoot, when the leak occurred and how it occurred, which location and all that. If you have a multiple leak detection system for redundancy, which is recommended, if one sensor goes bad, you have to make sure that you have a redundant system. That way, you protect the equipment better. So this is an example of, I actually took one of these pumped systems, a little pump on top of the CPU. All I did is I kind of cheated, taking off the pump and then connecting it to the leak sensor using the same fan header kind of connector. That's why the event log, it's looking for a pump, but actually not a pump, it's the leak sensor. So, and I was artificially simulating a leak, just putting a drip of water And then this is the event looker looks like. And I do have a little demo I can quickly show. There might be no audio on this, but you can watch the video. So normally these leak sensors are they're implemented inside a chassis. You don't have access to do this simulation, so that's why I'm using open system. This leak sensor, as you can see here, all I'm doing is just manually putting a drip of water, and based on the BMC setup, it will wait for 15 seconds and then safely shut down the system. Again, this is just example, of one way of implementing it. Maybe when you are implementing on your side, you could maybe have a different kind of mitigation plan implementation as well. So. All right, so as a summary, we demonstrated leak detection and mitigation system implementation on the server level. When you scale this to rack level or maybe the entire data center level, it's all will be different. So this is just the simplest and easiest way to demonstrate leak detection and mitigation implementation. So again, it's off-the-shelf sensors we can find in the market. We didn't do any kind of customization. Any customer can get these sensors from the vendors and implement it. To share some of the learnings, the voltage-based, voltage output type sensors seem to perform better in the sense the response is similar, but for aggressive conditions, let's say, for higher temperature, humidity, and all those conditions, you don't see any kind of drift. We noticed some drift on the frequency-based outputs, just a little drift from the actual specifications provided by the vendor. So something to look into on the implementation side. So, and again, on the mitigation, as I mentioned, we left the mitigation plan beyond the server to discretion of the customer. The mitigation plan, maybe if it is scaled up or to include the rack or maybe multiple rack, depending on, let's say if it is end-of-row CDU supported multi-rack system, and if you want to integrate all that, you might, the mitigation plan might be different. Instead of just shutting down the individual systems, you might even consider maybe controlling the CDU, or maybe you put a valve somewhere in the manifold and you operate the valve, stopping the flow to that affected or leaking server. So that's all left to discretion of the user. All right, as a call for action, this is the work on leak detection and mitigation we're sharing, and please share with the open community, similar kind of activities you're doing, and I think together we can come up with a robust safety and reliability mechanism we all can share and implement. And there is a bi-weekly meeting we have on the corporate work group. Reach out to the team here, Sean and Jordan, and yeah, participate. That's all I have. So if you have any question, please.